Hello students, in the last video we have seen how to sketch Bode magnitude plot and Bode phase plot. In this video we are going to see how to calculate the gain crossover frequency and phase crossover frequency. In addition to that, we are going to see how to determine gain margin and phase margin. Here in this particular problem, in the last video we have seen how to sketch the magnitude plot and phase plot. First, let us see how to determine the gain crossover frequency. Gain crossover frequency is nothing but the frequency at which the magnitude plot crosses 0 dB line. So in this plot, if you observe the magnitude plot at this particular point, it cuts the 0 dB line. So you have to sketch a straight line along this intersection point and you just calculate the gain crossover frequency. So it cuts the line along 1 radian per second. So my gain crossover frequency omega GC is 1 radian per second for this problem. So I have identified the point where the magnitude plot cuts 0 dB line and I extended the line to meet 1 radian per second. So whatever may be the frequency, that is the gain crossover frequency. Then the second point is you have to check where your phase plot crosses minus 180 degree line. So my phase plot is this one and it crosses minus 180 degree line exactly at this particular point. So this is the point where my phase plot cuts minus 180 degree line. So I am going to place my scale along this point to meet the frequencies. So I am going to sketch a vertical line, vertical dotted line along this point. So the frequency what I got is omega PC. Omega PC is phase crossover frequency and that is 7 radian per second. You can see this one 7 radian per second. So first part I have determined gain crossover frequency and second point phase crossover frequency. Now we are going to see how to determine phase margin and gain margin. So phase margin is nothing but the phase value at gain crossover frequency. So I know this is gain crossover frequency line. So I am going to extend this line to meet my phase plot. So always phase crossover frequency is taken from phase plot and it is corresponding margin at gain crossover frequency. Okay, so phase margin is taken from phase plot and it is corresponding to gain crossover frequency. So that particular line cuts the phase plot at this particular point. So I want to measure the range between that point and minus 180 degree line. Minus 180 degree line is the reference line for phase plot. So the range that exists between these 2 points will give you the phase margin. Now how I have to determine the range? So I have to count the line. So from this minus 180 degree line, let me count how many lines are present. So line 1, 2, 3, 4. So this point is between 4th line and 5th line. Let me take it as between 4 and 5. So each line carries 10 degrees. So 10, 20, 30, 40 and the point lies between 40 and 50. So I can take 45 degrees. So the range is 45 degrees. So this is phase margin. The phase margin is equal to 45 degrees. And I don't know what is the sign of this 45 degrees, whether positive or negative. So for that only we have written this sign convention, plus and minus. So if you see, sign convention for phase plot is plus above minus 180 degree line and minus below 180 degree line. So the range obtained is above 180 degree line. So it is positive. So the phase margin is plus 45 degrees. Now the next part is we are going to determine the gain margin. Gain margin is the amount of magnitude at phase crossover frequency. Already we have drawn the phase crossover frequency line and that line intersects the magnitude plot at this point. So the range between that intersection point and the reference line 0 dB line will give you the gain margin. So I'm going to measure this particular range. So range in the sense you have to check only the magnitude and not the sign. So I want to count from here. So from here, one line I have taken 40 dB. So one line is equal to 4 dB. So 4, 8, 12, 16, then 20, and it is between 20 and 24. So I'll take it as 22. So 22 decibels is the gain margin. And now I want to see the sign of this. So the range obtained is below 0 dB line, and the sign below 0 dB line is plus. So the gain margin is plus 22 dB. So this is how you have to determine the phase margin and the gain margin. So in our case, both phase margin and gain margin both are positive, and hence the system is stable. This is the way how you can determine the stability of the system using Bode plot. So we will discuss few more things on Bode plot in the upcoming video. Thank you.